So on Schoology, there's a handout that you can print out and take your notes on. So if you wanted to, feel free to print that out. If you can't print, then just make sure you draw the diagrams out on this, out on your notes clearly. So today we're going to talk about 4.3, corresponding parts of congruent triangles are congruent. And remember that abbreviation? CPCTC. So if you know that triangle ABC is congruent to triangle XYZ, then do you know if AB is congruent to XY? Yes, they are congruent. And they are congruent because corresponding parts of congruent triangles are congruent. So if we know two triangles are congruent, right? If we know that two triangles are congruent, then we can prove their corresponding parts are also congruent. All right, so we're going to look at these two problems, number 1 and number 2. We are going to state which postulate or theorem we can use to prove that the two triangles are congruent in each figure. Then we're going to explain how we can prove this statement. So step 1, looking at these two triangles, we have a double tick mark, so an angle, and a side. So these two triangles, triangle, I'll say NML is congruent to triangle PLQ through the angle side theorem, okay, because we have angle side. Now, how can we prove that ML, okay, this piece is congruent to QL? So since we know that these triangles are congruent through the angle side theorem, we can prove that ML is congruent to QL because corresponding parts of congruent triangles are congruent. So after we prove triangles congruent, then we can prove every other corresponding part in that triangle in those triangles are congruent. Let's look at number 2. So we want to prove that the triangles are congruent first. And I see a side with a single tick mark, a side with a single tick mark, and then what other information could we gather to prove that the triangles are congruent? I see a reflexive side there. So let's name which triangles are congruent. I like to start with S, okay, because I'm just going to start in the corner. So S and U match up. So if I go S to T, then I have to go over the single tick mark U to V. So STV is congruent to triangle UVT. And they are congruent through the side postulate. Now, we want to prove that angle STV is congruent to angle UVT. And since we know that these triangles are congruent, we can say that angle STV is congruent to angle UVT because these are the corresponding parts of congruent triangles that are congruent. So again, after you prove two triangles congruent, then you can prove that their corresponding parts are also congruent. So now we're going to look at a proof and see how this works in a proof. So we have our given, right? PR bisects angle QPS, and we know that PQ is congruent to PS. And we are trying to prove that angle Q is congruent to angle S. What I like to do, I like to mark a dot to what things I'm trying to prove congruent at the end. So notice how I'm not marking them congruent, but it's just a helpful way so I can keep in my mind, I know that I know that I have to prove that these angles are congruent. So let's look at our given. We know that PQ is congruent to PS, and we also know that PR bisects an angle. So angle QPS is over here. So I know for step 2 that angle QPR is congruent to angle SPR. And if we look at step 1, it's because we have the definition of an angle bisector. Okay, so we've addressed everything in our given, right? We've marked the diagram for congruence, and we've interpreted that bisecting angle and found what pieces are congruent. So if we look at this, our goal is to prove two triangles congruent. Our goal is to prove that the triangles are congruent, right? That's what we're going to do first. So how can we prove that these two triangles are congruent? What do you recognize? I can prove PR is congruent to PR through the reflexive property. And then is that enough information to prove that triangle QPR is congruent to triangle SPR? And they are congruent because we have side, angle, side. So after we've proven that the triangles are congruent, now we can prove that all their corresponding parts are congruent. So now angle Q is congruent to angle R, or angle S, excuse me, because corresponding parts of congruent triangles are congruent. So anytime you're using CPCTC in a proof, you must prove that two triangles are congruent first before you finish this last step. So this is how we can use CPCTC within proofs. Let's look at the next proof. Let's write down some steps first. So what we want to do first, we want to identify the triangles that contain the segment or angles we are trying to prove congruent, right? We're trying to identify. So remember, I put dots on those pieces. Okay. And then we're going to prove those triangles are congruent. Okay, the two triangles that have the dots in them. And then we're going to use CPCTC to prove that corresponding parts are congruent. So you're proving the triangles are congruent to then use CPCTC. Okay, let's look at this proof. Let me write down my given, and you can write it down as with me. We have angle 1 congruent to angle 2, and angle 3 congruent to angle 4. That is my given. Okay. So the first thing I want to do is mark the diagram for congruence. And our goal is to prove segment JL, okay, congruent to segment KL. So notice how we can't really put dots there because they're not angles. So you can actually mark like, okay, I want to prove those congruent, but make sure that you're not assuming that they're congruent to start. So the triangles that we're trying to prove congruent, triangle JLM and triangle KLM. Okay, we're trying to prove those congruent. So what's one more bit of information that we could state in our proof that would help us prove these two triangles are congruent? We got LM congruent to LM through the reflexive property. Okay. Now we have angle, side, angle to prove that these triangles are congruent. Okay. Now that those triangles are congruent, is that enough to help us say that JL is congruent to KL? So JL and KL are corresponding parts of congruent triangles, so they are congruent. So after we prove triangles congruent, we can use CPCTC. Here's another proof. I want you to pause the video, do this proof, and let's see how you did. So ask yourself, which triangles must be congruent? Okay, so you should have finished this proof by now, and let's see how you did. So let's address every bit of our given. Let's mark the angle W and Y congruent. Let's mark WZ and YZ congruent. And then we also know that this segment XZ bisects an angle. So which angle is WZY? That's this angle here. So I have a double tick mark, double tick mark. So we have to state that those angles are congruent. So angle WZX is congruent to angle YZX because of the definition of an angle bisector. So which triangles in this diagram are congruent? Remember, we're trying to prove those two sides are congruent. So triangle WZX is congruent to triangle YZX through angle side angle postulate. So now that we've proven the triangle's congruent, can we say that WX is congruent to YX? Yes, we can, through CPCTC. So recognizing, again, proving the triangle's congruent, and then proving that their corresponding parts are congruent. Okay, so I want you to pause the video, and I want you to try proof 4. Let's see how you do by filling in the blank. So given that angle P is congruent to angle S, and O is the that's our given, right? So you got to make sure you're marking that. And O is the midpoint of PS, that's also our given. And PO is congruent to SO. PO is congruent to SO because we know O is the midpoint of PS. So this is the definition of a midpoint. Okay. And then we have in number 4, POQ, angle POQ and angle SOR are congruent. What kind of angles are those? They are vertical angles, so we write the vertical angles theorem. Now, is that enough information to prove that the triangles are congruent? Yes. What's the postulate? Angle side angle. And now we can prove that QO is congruent to RO through CPCTC. But now we need to go one step further, because notice how your last statement, the statement that we want to prove, is O is the midpoint of RQ. So if you know step 6, then we can prove that O is the midpoint of RQ. So if QO is congruent to RO, then O is the midpoint of RQ. This, everyone, is the definition of what? It's the definition of a midpoint because we have the key word midpoint. Take a moment to think about how you did. Where did you make mistakes? How can we correct those mistakes? Okay. One last proof, I would like you all to pause and try to complete this proof entirely on your own. Think about how we can get to that last step. Okay, so we have XR bisects QT, and then angle Q is congruent to angle T. Okay. And we are trying to prove that segment QT bisects segment XR. All right, so since we're trying to prove that these pieces are congruent, QT bisecting XR, we need to prove that XM is congruent to RM. That is our goal. That's our goal because we want to show that QT bisects that bigger segment XR. All right, so here we go. From our given, QR bisects QT. So I know that QM is congruent to TM. This is the definition of a segment bisector. All right, so we have an angle and we have a side. Notice how we have a vertical angle here as well. So angle QMX is congruent to angle TMR. And that's the vertical angles theorem. So now these triangles are congruent through angle side angle again. And remember, our goal is to prove that these two segments are congruent. And now that we've proven that those triangles are congruent, we can say XM is congruent to RM through CPCTC. And then our proof statement. We can say that the, QT now bisects XR because of the definition of a segment bisector. How did you do? Take a minute to think about where you went wrong, what questions you have, and we will keep practicing with these proofs next time we see